Okay, when I say computer, what pops into your head? Probably silicon chips, right? Glowing screens. Well, what if I told you one of the most powerful computational tools in history was made of nothing more than simple sticks on a flat board? Today, we're going to unlock the secrets of the Chinese counting board, a forgotten supercomputer that literally powered an empire.
I mean, really think about it. Put yourself in charge of a massive, ancient civilization. You don't have spreadsheets, you don't have calculators, definitely no computers. So how in the world do you manage everything?
And that really gets to the heart of the matter, what you could call the ancient math problem. And this wasn't some abstract theoretical exercise. No, this was all about the super practical needs of a huge, growing society. Just think about the sheer scale of it all. You've got to count taxes from millions of people, you've got to manage grain reserves so nobody starves, and you need to figure out fair prices for trade. Not only that, you have to measure out huge plots of land for building projects and track the stars for the calendar. Yeah, counting on your fingers just isn't going to cut it. You need a system that's fast, clear, and powerful.
So what did they do? Well, ancient China came up with this absolutely brilliant solution. And it wasn't a machine with gears or circuits, it was something way more elegant, a calculator made of sticks.
This was their answer, the counting board. At its core, it was just a simple, flat workspace where you arranged these small rods to represent numbers. But here's the genius of it. The rods could be moved around, grouped together, taken away. It basically turned the board into a live, dynamic environment for doing math.
And this is so important to get. The counting board wasn't just a static thing for writing down the final answer. It was a physical tool that helped mathematicians see patterns, manipulate values, and, literally think with their hands. It turned abstract math into this tangible, physical process.
So how did it actually work? What made this simple board and a handful of sticks so incredibly powerful? Well, it all comes down to three ingenious secrets that were just way ahead of their time.
Okay, secret number one is a concept we all use every single day and probably don't even think about: place value. On the board, a rod's value depended entirely on which column it was in. A rod in this column over here means 1. But take that exact same rod and just move it one column over, now it means 10. Move it again, it means 100. It's an absolutely brilliant way to represent huge numbers with just a few simple symbols.
All right, secret number 2 was this really clever design trick to keep people from making mistakes. You see, if you placed all the rods vertically, a number like 111 would just be this confusing jumble of lines. So they came up with an ingenious fix. They alternated the orientation. The units column was vertical, the tens column was horizontal, the hundreds vertical again, and so on. It's a simple, smart visual hack that made the numbers instantly readable. Pretty cool, right?
Now, secret number 3. This one might be the most profound of them all: the power of nothing. What do you do when a place value is empty, like the 0 in the number 307? The answer? You just leave the space blank. It's so elegant. So for the number 307, you'd have your rods for 3 in the hundreds column and your rods for 7 in the units column. In that tens column, right in the middle, it's just empty space. That blank spot acts as a placeholder. It is the 0, and it keeps the whole number structure intact. I mean, that shows an incredibly sophisticated understanding of how numbers work. So you put these 3 secrets together: the place value, the alternating rods, and the empty space for 0. And the counting board became a true computational engine. It really did. It powered a golden age of mathematics in China. And we're not just talking about basic arithmetic here. Of course it could handle addition and subtraction, but the board was used for complex multiplication and division. And get this, even to solve systems of linear equations. You know, the kind of algebra that a lot of us find challenging even with today's tools. It was systematic, repeatable, and unbelievably effective. And you can see just how influential the board was when you look at one of history's most important math texts, the 9 chapters on the mathematical art. This classic book is basically a handbook filled with practical problems and their solutions, and all of them were designed to be solved using the counting board.
So what's a good way to think about this today? A great modern analogy I've seen is that the board was something between graph paper, movable digits, and a hand-powered calculator. It gives you that structured space, lets you physically move the numbers around, and helps you compute the answer. It's the perfect description.
Now you might be thinking, hey, wait a minute, isn't this just an abacus? It's a really common question, and it's a good one. But nope, they're actually 2 very different tools. So let's break it down.
The key difference is that the counting board used loose rods that you placed on an open surface. The abacus, which actually came much later, has beads that are fixed inside a frame and slide up and down. You can think of the counting board as the ancestor, the original innovator of this whole idea of physical place value calculation.
Ultimately, the true genius of the counting board was making a really abstract concept, place value, something completely visible and tangible. It turned numbers into patterns you could arrange in space, allowing anyone to literally see how math worked.
So, let's end on this thought. The counting board was a hands-on tool for thinking, right? A physical interface for complex ideas. And it really makes you wonder, in our super digital world today, what powerful, hands-on thinking tools have we maybe forgotten about?